Willoughby, we are back up and running.
Here I am, Professor.
I see your sunburn is fading, my young assistant.
Yeah, now I'm just appealing.
Yes, at any rate, through a bit of reverse engineering, I have hooked up our argon laser backup lights to the projector, which you should now turn on if we are to see more of the Science-O-Rama on solar power.
Right, Professor.
Dr. Charles Greeley Abbott, the Secretary of the Smithsonian Institution and the world's leading authority on solar radiation, says that before long we shall find a commercially practicable method of harnessing sunshine.
Financial success probably awaits the solver of the problem of collecting solar heat for power purposes.
He says,
with our present outlook, it seems to me likely that within another generation or two, power demands will lead to the sun as the most available source of supply.
over 2,000 years ago, a few wise men knew enough about solar radiation to concentrate the sun's rays for their own benefit. Among them were the pagan priests of ancient Rome, who occasionally allowed the sacred fire of the temple of Vesta, the goddess of the hearth, to go out, and then rekindled it by placing a piece of carefully dried wood in the focus of a canonical metal reflector, and letting the sun do the rest. Also, there is a classical story that the famed philosopher Archimedes, when a Roman fleet was attacking Syracuse in 214 BC, set fire to the Roman warships by concentrating sun rays on them by means of mirrors erected on the shore. It was in an effort to prove the possibility of this tale that in 1747 Buffon, a French naturalist, made the earliest known scientific experiments leading toward the utilization of solar energy. He mounted over 300 small glass mirrors on a glass frame so that each of them could be adjusted separately, and so that all of them could be made to concentrate their rays at any desired distance. With this apparatus, he set fire to wood over 200 feet away and melted silver at a tenth of that distance. A few years later, Hosen, a mechanician of Dresden, built a mirror 10 feet in diameter, whose concentrated rays almost instantly melted coins. Today, almost 2 centuries later, scientists still are interested in burning glasses. Dr. George E. Hale, astronomer at the Mount Wilson Observatory in California, recently designed a 15-foot instrument with 30 lenses that generates a temperature of 6,000 degrees centigrade that melts steel wire as fast as an ordinary gas burner would melt butter. About 20 years after Buffon's experiments, H.B.D. Saussure, a Swiss scientist, invented the solar hotbox, realizing that it is not until the sun's radiant energy strikes some material object that it is converted into heat, and that black, which absorbs all of the sun's rays, is the most efficient color for this conversion. He constructed a small wooden box, painted it black inside, and covered it with 2 sheets of plain glass, with an air space between them. Just how high the temperatures were that he obtained in this box when he set it in the sun is not known. But when, in 1837, Sir John Herschel used a similar box in Cape Town, a thermometer in it registered 240 degrees Fahrenheit. Sir John astonished his neighbors by using his apparatus for the homely purpose of frying eggs and stewing meats and vegetables. So it seems that his crude hotbox was a sort of rough draft of the solar cooker that in recent years
Again? We haven't finished a Science-O-Rama in one full swoop since the first one.
I'm sorry, Willoughby. That is all the backup power I could generate at this time.
Well, Professor, all I know is we need to get a longer source of power. Or watch shorter Science-O-Ramas.
Oh, my.
Waterlog Productions.